Okay, in this video I'm going to have a look for edc16 smoke maps or smoke limiting maps. I'm using the same SAT Layon 1.9105 file that I've used in the previous videos in this series. I say smoke map or smoke maps because edc16 ECU files often have several maps which are related to injection quantity and airflow, so smoke maps. So what I'll do then is, here's the torque limiter, which is where I ended the last video that I made. So I'm going to wander forward and look for something that might be to do with smoke. Now, I won't bother to mention exactly what this is, maybe I will at a later date, but that's a clue that I'm heading in the area that I want to go. So I'll just wander forward a little bit more, maybe a bit quicker than that. Right, now there we go, we've got a map there. It looks like I've clicked on it before because it says map Bosch there. So there we are. That's interesting because there's another map there which doesn't appear to be doing a great deal, but there is a map there. And if you look this way, I'm just using the mouse to scroll along, there's a map there, and which Windows hasn't identified, and then there's another one, two, three, another three maps there. So there's four maps there. So there's four maps after this one, and there's this odd one here. Now, I'll pay attention to this one in this video, and then I can always come back and look at the others later. Now this could be the injection quantity limiter that I'm looking for, so it could be a smoke map, and it could be based on MAP, in other words manifold absolute pressure, or it could be based on MAF, which is mass airflow. The series of videos I did on the EDC15, they were based on MAF or mass airflow. Okay, so let's have a look at this one. So I'll double click and open that up, see what we've got. Well, I'll do the obvious things first. I'll double click there and call that engine speed, because we know that's going to be engine speed. I'll put in there revs per minute. The numbers are all a bit okay, so we'll leave that alone. Right, now we've got output. Judging by the numbers it's going up to, 6,000, 5,000, these are probably milligrams per stroke of fueling, which of course that's what we would expect to find in a smoke map. So let's assume for the moment then that that's what that is. So I'll assume that that's injection quantity there, and I will assume that it's in milligrams per stroke, in which case this will need to be 0.01, and I'll have for now maybe just one decimal point after the decimal point. If I stretch that out a bit further, right, so that seems to be what we're looking at. So we're left with these figures here. Now these are not MAF, because if they were MAF they would peak somewhere in the region of 1,000 or 1,200, so these can't be mass airflow. They go up to 2,000. Now that's probably 2,000 millibars or 2 bars. Now it would be reasonable to expect our maximum boost to be somewhere in the region of 2,350, 2,4, 2,5, something like that. So this looks as if this is the pressure, air pressure, but obviously it's being pushed, so it's air pressure being pushed with boost. So this is probably boost air pressure here. So what I'll do is I'll just call that for now boost pressure, and that is as measured by a map sensor. So I'll put map next to it to remind myself. It's probably in what I tend to call millibars, but you could call HPA. That's another system that's used for these numbers, but I guess I'm old and I use millibars, but then of course millibars tends to be used on the weather reports as well, so I've sort of stuck with it. Okay, now if we say okay to that for a minute, so what we've got is we've got revs per minute rising, we've got available air through the boost map rising, and we've got available fuel that can be injected or is being injected rising as well as we come across. So that seems reasonable. Now I didn't give this a name, so what I will do is I'll give it a name. Now it's injection quantity limited by air pressure, which is often described as MAP. It can be a bit confusing, obviously, because manifold absolute pressure, and then if you were to say this is the map, it sounds a bit daft, but there you go. So, and of course for most of us that's just a smoke map. So what we've got is a smoke map. Now what I'll do is I'll extend this one very slightly for one good reason, which is that if we were looking at an edc16 we might not see this one, because we might see this, but it would be a measurement based on math and not map. Now in edc16s it's fairly common to find both. Sometimes both functioning, in other words, or apparently functioning, so you would have that map there and then next to it you would have another map, let's say there or over here, and that would be for math. So they would both have little squiggles on and look like functioning maps, and then you would need to work out which one was the one that was working. Now in this case I'm taking a guess, but I suspect that what we're looking at here is possibly another version of this, but the math version. But what's been done, it's been leveled out at a fixed value. Now that may be for emergency use, or it may be just for not use at all. So what I'll do is I'll have a look. Now an easy way of having a look at a map, which I may not have mentioned in the past, is to click where you think it starts and drag to where you think it ends, and then change view. You won't hit the exact right spot, but that doesn't matter because it puts you roughly in the right area, because now I can see that if that's a map, I've got 16, 13, so that looks like axes. 13 will be the width as I see it in front of me, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, so I'm going to want one more, so I shall add an M, and of course I've lost my highlight now, but it doesn't matter. Right. 16, 13, let's see, 16, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so that's where that axis ends. Right, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so, sorry, I've lost myself on the way. That looks like that's where that one ends. Let me just double check. Shows I'm doing this live and not making it up. Where are we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, there we are, 13. So what I'll do is I'll just press Control and the arrow buttons to move that to the beginning. Right, now if I've got that all in the right place, then I should be able to look up above and see a fairly sensible bunch of numbers at some point. So let's have a look at what numbers we've got. There's a 5 there, but that's 3, 5, 5, 8, 50. No, so I need to go one more. So I need to just go one more. Because if I look now, that's going to be the axis there, that row. So if you're beginning to get your eye in on looking at maps, you'll see what I mean. So what we've got there is 3, 3.5, 3, 750, 4. So that's going to be the axis for the 13 there. That's it there. So if I start there and go across, that's 13. So that's one row of 13. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that should be my map. So if I press K, now with luck, and it looks like it has happened, Windows has found most of this for me, and it has. There I've got what I should imagine is my engine speed, so I'll just put in there, engine speed, and in there I'll put revs per minute. I'll just OK that so I can get it out of the way. What we've got here then is almost certainly math, isn't it? Math airflow, because we've got, that's probably 850 and that's probably 1000. So that is mass airflow, I should think. It will almost certainly be milligrams per stroke. I'll just put of air as a reminder. This looks like it's going to need to be 0.1, and I don't think we're going to need any extra bits fiddled with here, so we'll just say okay. So that now runs up to 1000. So all we need is our output. Now this is looking like it's going to be IQ limited by airflow, which is math. And so that is looking like it's going to be our smoke map. Now I'm going to hazard a guess, and I'll just put next to it something I often do as a note to myself: not used, because I'm going to hazard a guess it's not being used. It may be used for an emergency of some sort, but I'm going to hazard a guess it's not being used. Right, so what we've got coming out of this map obviously is injection quantity, so I'm just going to call that IQ. I'm going to put in there milligrams per stroke, which is obviously the fueling. We know by now that that will be 0.01, and I'll give this 1 point after the decimal point. Let's have a look and see what we've got. Now, assuming that we've got this correct and we've got the correct map, this is set at 10 milligrams per stroke, which is not a huge amount over idle, which means that if this map is used at some point as a default, the car may well tick over, but you're obviously going to be struggling to drive, I should imagine, because the fueling is going to be limited to virtually nothing. So we'd have a little bit more than idle, so we would not just have limp, it would be sort of super limp. It's possible this map's not being used at all. At a later date I may go into showing people how you can work out roughly whether a map is being used or not being used. It's not an exact science, but you can sometimes pin it down. Okay, so there you are. You've now got two possible smoke maps. You've got a MAF smoke map and you've got a map smoke map, and it looks as if it's the map smoke map that's being used. So it looks like that one's not being used and this one is, which still leaves us with something here, and again there, and again there, and again there. And they are going to be related to fueling and air, probably because they're in exactly the same region of the file. You can never be sure with files because sometimes the designers jump around, but occasionally, and certainly in a lot of the early files, things tend to flow. So you tend to find that everything to do with air is in a similar area, but not exactly. Okay, I'll stop there, then I'll come back to those other three maps in another video.